Okay, hello. We're going to go over side, angle, side. Similar triangles. S's are sides again. A's are angles again. All right. The A, seeing that it's side, angle, side, see how the A is in between the two S's? That is called an inclusive angle. It's in between the two sides. It's sandwiched, right? So side, angle, side. It must be an inclusive angle. That is like really, really crucial. It can't just be any angle. It has to be a specific one, and that is inclusive. It's included. Meaning when the two sides come together, that angle created is the A mentioned. Okay, so we're going to go through it. So this is very much visual. Okay, must show two equal ratios and an equal inclusive angles. Remember, for every side, there has to be a ratio. So ratio, which means these two ratios reduced down must be the same fraction or decimal. And this angle better be a pair of equal angles. Okay? All right, so all the triangles similar? Yes or no? Give me number support. It's a must. If yes, give me a similarity statement. Okay, so let's just kind of... And it's because the assignment is only going to be like 3 problems. Like if you see here, right? Whoops, sorry. If you see there, it's only 3 problems because then I'm going to upload a worksheet and we're going to do that together. Okay, so here we go. Let's take care of the sides first. All right, so I have 2 and 4, and I have 5 and 10. Okay, 2 is the smaller of the 4, and 5 is the smaller of the 10, right? So if you're like, wait, how do you know how to put them together? Well, 4 is the bigger number, 10 is the bigger number. So I'm going to put my smalls together. I'm going to put my larges together. Okay, I will go small to big. So 2 over 5. Okay, next. My 4 will go with my 10. 4, 10. Okay, and now what about my angle? I have vertical angles right here, right? Vertical. So I have angle... Oh, should I do? You know what? I'll do this. And I'll make it an A. Let me write with pen, though, so you can actually see it. LOT, angle LOT, to angle QOR. Okay. So I have my A. Vertical angles, right? There's my pair. Okay, so now let's get back to this. I need to reduce that down, but 2/5 is actually already reduced. Okay, so let's go to 4/10. If I reduce that into punch it into a calculator. My bad. 4/10, I get 2/5. Okay, so this reduces down to 2/5. See how they actually are equal? Yes, they're equal. So that means that is my scale factor. So that means because it's a consistent fraction, I actually do have side. And then this is my inclusive angle. So I have side, angle, side, side, angle, side. And so the first S comes from the pink, right? The A is my inclusive angle A from vertical angles. And then the 4/10 reduced down, there is my side, angle, side. So yes, they are similar. Okay, you got to give me a similarity statement. We're going to go pink, yellow, teal. So triangle LOT, similar to triangle pink, yellow, okay, QOR. And there's my similarity statement. That's it. Okay, second one. All right, so here we go. Make your ratios. Okay, 10 is less than 12, so I'll put 10. 50 is less than 60, so I'll put 50. Okay, so next longest length is 12 and 60. 12 and 60, right? Okay, now let's look at my angles. I have, whoops, did that fall? Oh no, okay, sorry. I have this R is to this Z, right? So I do have an angle. Okay, so angle R, oh wait, but I first started with Z. Angle Z is congruent to angle R. By the way, if you went RZ, I wouldn't dock you. Just figured, since I'm going small, big, I just want to keep that order. This is an angle Z, by the way. Okay, so now get a calculator, reduce it down. Okay, that can be reduced to 1/5. What about 12 over 16? It's still 1/5. 12 down 60? 1/5. Okay, notice they are equal. Lovely. So my scale factor is 1/5. However, this is actually a no. So look, it is side angle side. The angle must be inclusive, in between. That's not what I have. The inclusive angle is S. The inclusive angle is W. R and Z is not an inclusive angle. So what you actually have here, and no cursing, right? I'm not, is you don't have side angle side. If you go in this direction, you have SSA. Or if you went in this direction, you would have ASS. You would get the arc of the angle, side, side. That does not prove similarity, so it is not similar. The fact that my ratios worked out, great. But you don't know. You can't gather enough. Now, they could be similar, but you would have to know what this is. You have to know the inclusive angle, not this one. Okay, remember, it's side angle side. Okay, so here we go. 3. Again, let's make our little, okay, 6. Oh, I guess I'm going big, small now. So 6 to 3. And then I went big, right? 14. 7. And then let's look at our angles. I have 90, I have 90. So what did I start with? So this is an A because this is angle B is congruent to angle R. Okay, so now break this down. Whoops. 3 goes into 6 2 times. 7 goes into 14 2 times. Yes, right? My scale factor, my K, is 2. Oops, sorry. But now you have to check, do you have side angle side? Okay, so you look. I have side, side, angle. Okay, so if I look at this triangle, if I go in this direction, I have angle, pink, blue. Angle, whoops, side, side. If I look here, I have pink, yellow, blue. I have side angle side. This angle is inclusive R. This angle B is not inclusive. This 14, right? You technically put 7 and 14 together, but technically, or at least I did, well, blame me. I put them together because they were only 2 numbers. But look, if you remember right triangles, these are legs. This is an hypotenuse. The 14 is a hypotenuse. 7 is a leg. You can't put 7 together with a hypotenuse. So even though it appears as though you have a scale factor, and you're like, oh, look, my angle R, it's inclusive. Yes, but over here it's not. So they're tricking you with the order. So this is actually not similar. Okay, so then lastly, here we go. So let's go pink. So 6 to 12. I have 1.75 to 3.5. And then if I look at my angle, I have 40 degrees, beautiful. So, oh wait, you have an A. I have angle S is congruent to angle K. And so far, it looks like an inclusive angle, right? It's in between the pink and the teal. It's in between the pink and the teal. That's an inclusive angle. So far, it's looking great. Okay, so all we have to do is just prove that this is 1/2. 612, 1/2. 1.75 divided by 3.5. It is 1/2, but let's check. 1.75 down 3.5, 1/2. So I actually have a perfect side angle side here. 1/2. That is my scale factor. And so this is side angle side, right? The pink is from the pink corresponding sides. The teal is from the teal corresponding sides. And the A is from that inclusive 40-degree angle. Okay, so what is your similarity statement? We'll go pink, yellow, teal. So what did I go small? Okay, RSE is similar to AKL. And there you go. Okay, your assignment is only 3 problems. Okay, so I'll upload this as a PDF. All right. Okay. All right, bye.